at least a little bit late, but as close to on time as possible. Hi, thanks for coming. Alex and I are going to talk about defining and building identity graphs, why you need them, why they're cool. It's a little bit of kind of prep talk for the role that Gartner defined a couple of years ago, which is called the identity data engineer, which is something that's an up-and-coming thing, which I think is going to be a bigger and bigger thing as identity becomes more and more critical. So, without further ado, let me introduce myself. My name is Didi. I used to be CTO and co-founder of a company called Ort, which is now part of Cisco, and I work in the engineering group. Alex is my head of data science for both Ort and for the current group that we're in. And the data scientist is probably the most important role in this identity data engineering group because they're the people that actually consume the data, make sense of the data, and are able to take actions or recommend taking actions based on the data. Does that make sense? Awesome. By the way, I'm standing between all of y'all and lunch, so I'll be speaking fast and try to be as efficient as possible, but do feel free to ask questions at the tail end, and the more we interact, the better it is. So, what are we going to talk about today? First, we're going to talk about the chaos, which is today's identity landscape. I think if this was a simple space, I think we wouldn't need this conference and all the stuff in the exhibit hall, but it's very, very clear that identity is a complicated topic. Second is, why do we need this identity graph? And why do we need a graph, not just a simple big-ass table that everybody can select from, or just put everything in a sim and it will work magically? So, we're going to talk about that. Then, I think part of the idea of a master class is to teach you how to build one. Because the idea is not to try to tell you, hey, buy this, because there's no magic bullet. There's no silver bullet that will solve all of world hunger. We need to teach you how to build something like this on your own. And then you can decide how to mix and match to see what you can do to build something like this on your own and leverage the tools that are in the ecosystem. We're talking about how to leverage the data. That's the part where Alex is going to talk about. And we're going to bring it all together in a couple of examples. And, of course, a demo, how it looks like and what we built. But it can give you an example and a thought of what you can do on your own with your systems. Does that make sense? Thumbs up? Awesome. So, the identity landscape. This is a little bit on the marketing side, but I think the not marketing side would be a lot more chaotic because nobody has one idea. If anybody tells you, hey, we solved everything and we put everything into Azure or Entra or whatever it's called these days, or Okta, they're selling you something. Everybody has more than one IDP. Actually, you don't know how many IDPs you have in your organization. And that's the challenge. And when you think you have everything under control, you have your processes that deal with humans. You have your processes that deal with machines. You have your processes that deal with how to get things done, trouble ticketing systems, with how to deal with sales, how to deal with code, how to deal with add whatever you want. And each one of those systems actually harbors identities. And the worst thing about them is they don't know that they do that. They don't know what data they have. And once you expose that data, it becomes very, very clear that that needs to be protected and enforced. So what is the problem of our identity space these days? And I can read off the slides, but that's never helpful. I can tell you my personal view of this. Prior to going off and building a startup for Cisco, I owned a big instance of Okta. And that instance of Okta, I started having questions of who actually is MFA into my system? And that was a hard question to answer because I thought I knew, but then people came in with federated IDPs. Some people had long-lasting sessions. It was really hard to come back and answer how many people actually have MFA, and if they have MFA, which factor did they use? That was a very hard question to answer. Then I started asking myself next questions of what systems are they using? Because we built this as a SIAM solution. By the way, I'm seeing a big uptick these days in the SIAM space, which is really, really cool. But this was a SIAM solution of basically giving people access to our systems. We had over 20-something systems. We wanted to know which systems are being used, which ones are not, which people are. Also, if you think of a SIAM relationship, you don't actually own the identity at the tail end. Somebody might have left the organization that they were in. How do we know that this is a dead user? And how do we know that that dead user was not taken over? All these are questions that come from the fact that we have very limited visibility into what's happening in our IDPs. Because sometimes we end at the login and we never follow up. Sometimes the infrastructure is fractured. They don't pass the transaction IDs between them. We don't know how the transaction rolls out. Second, the protection itself. If you think about it, everything in our systems is built to enable people to come in. We want to let people in. We're not like the TSA. There's a whole bunch of examples of a whole bunch of my peers that talk about airlines. It's a really interesting thing. But we're not built like the TSA. The TSA is the office of no. Their default is not to let you in. You need to prove to get in. In most of our systems, we want to make people be able to work. Our help desk systems want to help. We hear them with people that want to help. But that is also the vulnerability of the system. Because somebody calls up and says, hey, I'm somebody, somebody, somebody. And they can come in. So our protection by definition is frail. And then our enforcement controls. If you look at Okta's roadmap and Microsoft's roadmap, they'll tell you that they have security features into their identity. We kind of tell them, no. Identity and security, they're the same thing. But you'll see that a lot of the identity systems have what is called security bolted on versus built in. It's another phase. So the policy controls are not there yet. They're not as mature as other security controls like we have on our EDRs, XDRs, and things like that. Kill session, build sessions, deal with a lot of those things. So our enforcement itself is very limited. Think of the fact that I discover that somebody has a breached session. How do I kill such a session? How do I come to make it the decision that I kill the session, and how can I actually enforce this? You'll see that very few applications respect the kill session. So this is my identity ecosystem. I have limited visibility, frail protection, and very limited enforcement. Does anybody think that I'm wrong at that statement? Not so much. And as I said in the beginning, we have so many IDPs that we don't even know about it. Our CISO came on and said, there's 3 official IDPs that we have right now in the organization, but I know that there's closer to 30. And getting that visibility into what is actually used as an IDP, because people can use Salesforce to log in. Half your sales team is probably doing that and you don't know. They're logging into clickers and things like that. Your GitHub can be used to log in. If you have companies that came in through an acquisition and use GitHub and use Google, they can log in with that. You have a lot more than you think. So why do you need a graph? Because you need to build the relationship between these things. You need to build a relationship between those entities, each of which eventually transforms into being that core identity. And that is well built and well served by building a graph, not so much a table. And why is that? Because as of the writing of this is a conservative number. I think in last Identiverse, some of my peers were talking more towards 84%, 85%. I actually believe it's closer to 90, but these are confirmed. So this is the lowest bar, is that at least 3 out of 4 breaches start with account takeover at some level. And why is it so prevalent? Is because COVID happened. We let everybody work from home, and no, that genie is not coming back. Nobody's going back to the office. I like my morning workouts. I have now 244 weeks straight with Peloton, workout every single day. I'm not changing that. So, if you think about that, nobody's going back to the office. You need to support remote work. Companies have built entire infrastructure to support remote work. And for at least information workers, it's really helpful. But it made the fact that the only protection that stands between your information systems is at best a password, or an MFA, and maybe a VPN. We have this nice little group called Talos in Cisco. And this is the fun part about going back to Cisco. Things that I hypothesized before, now I have data to prove. Most of the common MITRE attack all start, at least those that are seen, start and end with identity. It's just so easy. It's so simple because, as I said, the system is built to allow people to come in, and therefore people abuse it. What do? We need to think in terms of these elements. We need to think of users. We need to think of machines. And when I say machines, always think in one of three elements. You can have a workload. You can have what is called an associated device, like your laptop, your phone, whatever thing you're using to access or authenticate, which is different than where the workload runs. And then you have the IoT stuff, the MRI in the hospital, the manufacturing here. You need to separate those and know how to enforce each one of those elements. You have those services. Remember the workloads? They have a service that's associated with them. Who consumes this? And by the way, this is where I inject my philosophy. Every one of those things needs to have a person associated with them. And actually two people. A business owner and a technical owner. Somebody that can reset certs, deploy the system, but also who is accountable, who pays the bill. If it's an MRI machine, who pays for the electric bill? MRI machines consume a lot of electricity. Somebody pays the bill, somebody makes money, somebody needs to be accountable if this machine gets breached. Same is true for the workloads, same is true for the attached devices. The attached devices are simpler because they're usually somebody that's associated with somebody. Same goes for applications, same goes for data. The data itself needs to have somebody that owns it, because if it gets extricated, somebody needs to be responsible. And of course there's behaviors of how all these things interact with each other. And that's how you end up with this nice identity graph of building the relationship between those elements. And you need to think of how those systems interact with each other. Now this seems very, very theoretical, right? Well, actually it's not, because my boss, very, very sharp lady, came to me and says, yeah, you showed the slide, but nobody believes you that the system actually knows about all this stuff. I told her, okay, I have a great UI designer. He's not here. His name is Nico. He's amazing. And he gave me this in less than 4 hours. And this, by the way, is me with all the relationships of how I log in. And by the way, the devices is missing just because it looks ugly on the screen. But it shows which devices I use to which system. And yes, I live in Massachusetts. By the way, nobody actually lives in Boston. Everybody lives in some township somewhere between 128 or 495. So I live in Newton. And sometimes I travel. And actually, if you would have seen my graph to this since I came back to Cisco, it has a lot more travel than I want. And you can see how I access the various systems. And why is seeing this graph so powerful? Alex and I were on a customer call after we released this, because we thought that this is nice and gimmicky, and we'll show this, and everybody says, yeah, this is awesome. You can see the graphs, you can see the pretty colors. And then one of our customers said, it took me 3 seconds after looking at this graph to see that somebody's attacking me from Russia. Nobody's supposed to be accessing from Russia to those systems. And this specific user that we turned into Fu at example, not only that, they're not using an Office 365 client. We've seen multiple CEOs show up using, and successfully using, the Microsoft client through STS. That is not the CEO of the organization. If you're lucky, that's the support team trying to reset something for him. If you're unlucky, that's somebody leveraging the Microsoft STS vulnerability. And they're coming in. Getting this to be this visible solves problems. Because one of the biggest problems you have with the identity mess, as we described before, is to understand the transaction end to end. Because you go through multiple systems, and you're able to deal with clear visibility into how to at least diagnose. If you diagnose, you're halfway there to solution, right? Now, how to build your own. AWS. Well, you don't have to use AWS. You can use Google and you can use Microsoft, but we use AWS. And you need to think of user data in several elements. Element number one is velocity. So when you deal with SIM systems were born to deal with firewalls. Firewalls emit session creation information, and that is a very high velocity, high output piece of information, but it's also very point specific. You need something that's able to store a lot of the data, but you need to start with what I call the metadata. If you need to think of what the metadata is, look at the SCIMS spec. Where's Nancy? Hopefully she's in the crowd somewhere. Yes, Nancy. Thank you for doing the SCIM thing. The SCIM thing gives you at least a baseline of an understanding of how you define that user entity. Fill out that piece of information. Go around, understand your users and your groups and your applications, and build the relationships between them. And that data is vast, and the relationship graphs are complicated, so you need a lot of space to store this, but it doesn't change a lot. That is like the outline of the graph of the users. This is where you start. Next thing, you'll notice that we also added something that deals with streamline and streaming information. So you have to have that structured data, and then you have to add the event-based semi-structured data. And why is that semi-structured data so important? Because the events, think of this as like color by numbers. It highlights where are your hotspots. Is the user using specific systems? Is this system related to many users? What is the interactions? This kind of highlights the weight of those lines in that graph that I described before. Builds that weight into how things are in that graph. Now that combination of very mass data that is doesn't change a lot. Think of most people that you know, or most systems that you know. You don't release systems every minute. You release systems weekly, monthly, yearly. That doesn't change a lot. People change names, but not that often. You add employees and you remove employees, but the half-life even of call centers is 8 months. So that change is not as hefty, but the actions that they do is. And in the solution that we currently use, we use Snowflake as that baseline for the events, and we use Elastic to build the graph. And you'll ask why you're not using a GraphDB. Probably everybody's thinking, oh yeah, there's Neptune, there's Titan, there's all these things. A lot of them are built to navigate through straight logic. You want to have a straight line of navigation. If you think of really good solution for a GraphDB, that would be an XDR solution. Because things go from state to state to state to state, and those states are finite. With people states, they're never finite. If you think of yourself every time you wake up in the morning, you kind of are certain of what you're doing, but not. People always live in that constant state of uncertainty. And therefore you need something that is good with dealing with fuzziness. And for us, Elastic was that. And you need to search. Because the big thing, as Alex is going to show, is you have a lot of questions. And that's kind of how we ended up with that element. And the last thing that you need is a good BI tool. We love QuickSights. I'm not saying that you should marry Microsoft, the QuickSight thing, but we love QuickSights because it allows you to ask good questions very fast, link the data, and get a nice graph to answer the question. I'm not saying that that's the only thing, but it's really cool that they've added a lot of the insight tools and a lot of the intelligence tool and a lot of the AI tool. Tomorrow morning we want to say, hey, we're using AI. QuickSight very easily allows you to take the complexity of elk and make it into something that's human accessible, of asking a question that translates into elk calls, that turns into nice graphs. Like, show me all the users that I have in region X accessing application Y that don't have strong factors. And this is a question that comes up in a compliance-based organization almost every other day. And you need to show this in a graph that's for the C level, but you also need to have that translatable after you give it to the C level. You need an Excel spreadsheet that comes out of that to say, okay, let's fix this user, let's fix this user, let's chase this user, let's fix this user. Here are the managers that I need to call. And preferably, by the way, think of if you can automate that into something like a Slack or like a WebEx Teams or like a Teams to send managers nice nastygrams to say, hey, half your employees are not compliant, go fix it. That makes it very, very friendly towards the IT teams. So that's kind of where our mind was at when we went off and built the system. Important thing, you need to think of how you link between users and systems, and you need strong IDs. And you need to have them in what I call a cascading thing. Everybody starts to think, oh, we need to have all this fuzzy logic, fuzzy matching, but start with the basics. Email is one, name matching, and try to enforce some level of employee ID. And if it's a customer, customer ID, and percolate it. AD has that, Okta has it, Duo has that, Ping has that. Just make sure to use those fields, populate them. If you don't have them, push for them. If you don't know if you have them or don't know if you have them, get something like this so you'll know. And then you can try to start having those matches. And make the system flexible in terms of the ability to do the matching. Leverage IP, user agent string, and things like that to come back to prove that the user is linked to the user. User A is linked to user B. But don't start with the hard part. There's enough things that can just work with the simple tools to start with. For example, in almost every conversation that we have with regards to entitlements, everybody says, can somebody has a minor capability in some subsystem? Like, how many people have this sub-capability, like billing in AWS? And the first question you need to ask them, do you know if they even log in? Because what we are seeing right now is everybody's trying to circumcise the mosquito with those little minutia, when you can just start by kicking out everybody that's not logging into the system. So think big rocks first. And we're going to answer for you 2 questions. We have this concept called checks. Everybody has this concept of, am I okay, am I not okay? And have a nice little dashboard like this to answer your first question of, like I said, am I compliant? What are my frameworks? Bring in whatever framework that you like. We're not recommending any of them specifically. Pick whatever framework you like, but check, are you compliant towards this? And then understand, what is the state of the user? Is this user in a good space or not in a good space? Everybody talks about user risk, and we have to deal with user risk at some point. But if you don't have the ability to answer this question of what is this user doing, you can't do risk effectively. You need to understand the user before you can look at the population. You need to understand the individual before you understand the population. And with that, Alex is going to show you some cool stuff.
Thanks. Did you give me a moment to connect my...
If you need me to do a song and dance as people come in, because I'm really bad at dancing.
I'll keep it like that. Thanks, Didi. And I've heard that we have this AI software that summarizes all our discussions. So I would like to start with making this AI software simple, and to say that I hope you understand that all the identity security part is about the data, right? Like, and if you want to make good decisions, we need to make sure that we have a good data. And yes, I'm a data scientist, so I'm biased, but it's not just me. And from my experience, if you have, you've probably heard this a lot, if you have like garbage in, you will get garbage out. So a lot of the things that Didi described, like technically what platforms do you use, what protocols, whatever, it's nice, it's important, but don't forget that the main part, the main kind of thing that will help you answer the question if you comply, is the quality of the data that you feed into your identity graph. The second part is kind of to give you like through those examples, I show you that there are many teams that will benefit from this identity graph. So it's not just the IT or not just the security team. It may be your call center that will have visibility into some user attributes. So when someone calls and tries to do like a deep fake on a user, the call center representative will have more evidence to check against before he enrolls a new SMS method and enables the attacker to get into your organization. It can help your legal team. It can help your finance with, and I'll show you, like with, or procurement with assessing license usage, and might save you some bucks. And we've seen a lot of examples across different teams that suddenly, when they have access to this data, and suddenly it's not just data that's in Splunk in your, I don't know, CISO organization. It suddenly, teams suddenly become more proactive, and they're like, can we ask this question? And can we ask that question? And can we improve user experience? And by improving user experience, we can also improve the security posture. So a few examples, and I'll come to my laptop to show you. So I'll start with, like if we're in a space of ITDR, so I start with the detection, right, and the threats, and how we can detect stuff. So I have a cheat sheet for links to show. And I'll start with a simple example of probing. And you see. So one of the indicators to understand if account has, if something bad happening to an account, is there a malicious intent with certain events, is to look if the account is being probed. If somebody tried to guess the user password, it sounds maybe stupid, because many IT admins, they're like, no, we have MFA, so we don't care about all those who try to knock on our door. But in this example, and this is our lab, so I don't want to show this data. One of the things that we check, for example, so we know that this account was inactive for a certain period of time. We detected that the account was probed. So suddenly a few questions came, like when you easily see this data, you have several questions you can ask yourself. So first, do I still need this account, right? If this employee, maybe this employee was already left the company, and maybe this is the employee itself who was trying to, I don't know, download something from your network. But this is the first question. The second question that you can ask yourself is, for example, you think that you protected because you have MFA, but when you look on this account authentication factors and their usage, you can see that, for example, although the account has multi-factor authentication with Okta Push, actually this account mostly uses SMS. So maybe this account is not that protected as you hope to be. So suddenly, again, like when you get this data, across the systems, you can see more, you can ask more, and be smarter with your decisions. Another example is MFA flood, MFA fatigue. I don't know how to name it. It's a case when an attacker targeting push notifications, it sends you hundreds of push notifications to your mobile device, and the user, in order to stop the buzzing phone, just at some point accept and logins. This is interesting. It's highly correlated to something bad happening, because this is not a typical case how users authenticate. They're not, here's, sorry, wrong, so this is an example in Duo. The account you see kind of got multiple pushes and then success. So this is not how a typical user would work. And therefore, it's interesting to take a look on that kind of activity because it's highly correlated with malicious intent. Though, to be honest, while analyzing these cases with our customers, we realized that this is also a good indicator for technical issues caused by awkward VPN services and networks. Because sometimes legitimate user tries to log in, sends a push notification, but because of the network he's on, the notification does not come through to his phone. So the user kind of clicks and clicks and clicks. So this helped us to identify users. So it was not a malicious intent, but it was a behavior that the company didn't want employees, didn't want to see their employees. It's like connecting to awkward networks. So they were like benefited from that in a different way. Another case of threat of a behavior that is highly correlated with malicious intent and threat activities is impossible travel. So I hope you all know what impossible travel is, and everybody do that. I'm not saying that it's the best thing. It's nice. We find it's extremely noisy. As I told you, the data is a mess, and I think we added about 20 conditions to the basic, hey, user coming from one country and another country. So we had about 20 more conditions to make this detection more or less sensible for customers to digest. Because nobody wants to get yet another 20 alerts from another security solution or from another team. So, and again, how identity graph helps is also with explainability to say that, okay, so we detected those events. The first event was from this place, the distance was that, we identified it in Okta, and to give you a bunch of information about the IPs, the commonality of an IP for a user, the commonality of IP for an organization. So the more data you put in your identity graph, the more accurate assessment you will get. The user agents and the behavior part. So it's all, they all see it eventually in the identity graph. Another interesting, so I have a few more examples that are dealing with locations. And so from one hand, location is a very important attribute of malicious activity. Like when we analyze real breaches, real credential theft and credential abuse, the location was a very important and critical part of the analysis. With that, the genuine user population was also messy because people change locations, people move and travel, and like Didi showed you, there was a period he was around the world. So it's a bit tricky how to balance this, but few angles that I want to share with you. Denied countries. So this is, as the name says, US has embargo on certain countries like Iran, and companies that are US based, they want to make sure that they don't have traffic coming from Iran because they need to be compliant. And so the initial list of denied countries contains those blocked countries. An interesting case we've seen in one of our customers, when we released that, I called them and I said, hey, you have like 15 employees in Belarus. Like, did you know that? And they're like, no. And they started an investigation. And what happened is that they outsourced a development team into some company in Europe. The company, based on their contract, said that they will hire employees in certain European countries. I don't remember where. I think it's Spain or something. But the company probably wanted to save some bucks and hired employees in Belarus. So simple. It's not too malicious, right? And from one hand, but it can help you to see some awkward anomalies that will make you compliant and can create a mess. And we use the data that we have in our data graph to support legal and the IT, of course, with investigation and the following decisions that we make. Another interesting thing that we see a lot, and it's a relation between user register location, like when the company thinks the user should be, or when the user, and it doesn't matter if the company is remote or not. Typically, the user says that, hey, I'm living in Texas, and there is a location associated with the user. So there is a working location in the right left corner, for example. You can see that this specific employee is from California, and where the user actually lives, works, authenticates from. And by analyzing those two, we can first detect threats, because rarely we will see somebody actually, like an attacker actually mimics the legitimate user location. And also, again, with finance and legal, there are some cases when the employees cannot work from certain states because of compliance regulations and whatever other things. And so this kind of simple analysis, in theory, is possible only by the fact that we bring all the identity sources, all the user data into one place, and we can say, hey, for sure, this account working from China. And we had a case when an employee said that he's going to work in, I don't remember what, in US basically, and he at some point relocated to China and was using VPN to hide himself. And again, but we managed to see that he's coming from China because his mobile phone, he put a VPN on his laptop, but he forgot to put a VPN on his mobile phone. So each time that he authenticated from China. So if you want to be smart if you're doing bad things. This is stupid, right? But this is kind of, but most of the cases, they are like that, right? And when it becomes funny and simple only once you have the data, right? Like only once you see this in front of you, you're like, like come on, you can do better, right? And then, and as I mentioned kind of about VPNs, I think in the past, at least for a breach analysis that I participated with and investigated with our customers, a personal VPN was involved. So again, it's, and as Didi said, you think, especially big companies, you think you have one IDP, you think you have one identity source, you think you have a good policy in place. Apparently, it's not always the case. And we see, and this is a very common and actually, to be honest, sad feedback that we get from customers when we show them, hey, do you know that you have users that using VPNs? Most of that is they're like, but I have a policy in my Okta to block that. And okay, like, I don't know, but here's the evidence, right? Like, I'm not saying that your policy is good or bad. I'm just saying that people find their ways to do their stuff. So maybe your policy is okay, maybe they bypass it through Salesforce or through GitHub. I don't know. Like, I know I can show, but my point is that VPN usage is something to monitor, because what you will learn in any organization, we see this a lot. There is a group of people that prefer to use VPN. So once you know that they exist, and whether you're okay with it or not, and you exclude them, everybody else are going to be really suspicious, because most people, normal people, they don't use VPNs to log into their, Drive or WebEx or whatever they use. So this is like from a threat perspective, few things that we do to help organizations actually to detect malicious intent activities. A different angle, MFA, it's kind of a compliance, it's user experience. And from a compliance standpoint, as Didi said, one of the basic questions that most organization has to be able to answer is to easily see all the accounts that have no MFA, right? Like again, it's easier when you have access. Like you can do this with one click when you have the data. And it's also, as I said, like different teams will benefit from this data, right? SOC analysts might not care about it. And they from my experience working with Cisco SOC team, they don't like when other teams come to them and, hey, can you get me this from Okta? Can you get me this from Azure? I need to see it. Like, this drives them crazy. It's not their job. They're wasting a lot of time on that. So data democratization can actually really help the organization to be more effective. Another interesting observations that we had about organization policies is shared authentications. Authenticators, accounts that simply share the same MFA method. So in this case, we have like 2 accounts, and each of them is sharing the same phone number with each other. So a real example, once I started working on this analysis, I come to one of our customers and I'm like, hey, you know that there are about 8 employees that have exactly the same phone numbers. What's going on? They did an investigation. Apparently, the way how their employee setup works is that the IT that provisions the account, the IT administrator that provisions the account has to do the first MFA by himself. And then they kind of give the user, the new employee, the ability to enroll their method and to change his password. And what happened in that specific company is that 2 IT employees, they just forgot to delete their phone numbers from the organization. So eventually, they kind of, at some point, they've got around 200 employees sharing 3 phone numbers. And it's potentially a big security issue. And again, this is something that you can see, again, once you start correlating those pieces.
Alex, I'll also pause you here for this important element of the shared authenticator. The shared authenticator is something that we built kind of on a whim, and it proved to be one of the most valuable elements ever. And by the way, if anybody here is a vendor, please, Okta and the rest, share the serial numbers of the FIDO keys also, because sometimes they do this and sometimes they don't. And when they don't, it makes it more difficult. But shared authenticators helps us deal with a lot of boring stuff. Like, almost every organization has super admins linked to their real admins. That shared authenticator is the easiest way to know that those shared accounts exist. And why is this so important? Is because organizations are really, really good at cleanup of the joiner, mover, leavers of the main account. So I leave Cisco tomorrow. Cisco will be very, very good at killing my main user. The 15 linked accounts that I have as super user in a million systems, they're not very good. I'm describing a hypothetical situation that may or may not have happened, but let's say some people left organizations and came back, and they discovered that they're still the super admin of Amplitude and Google Analytics. Just a hypothetical. So this is something that happens a lot. That shared account visibility is the easiest way to enforce that linkage. So think about that. The other one is what I called C-level vulnerability. Almost every C-level person that you have in your organization yells really, really hard. They really are good at yelling really hard. That's how they got the C-level. And because of that, everybody's afraid to tell them, hey guys, you're breaking the policy. And you'll see that half the IT team has access to their account through those share authenticators. I'm not saying fix it, but sometimes it's really helpful to your executives and their executives to come to the C-level and say, hey, are you aware that you're doing this? Because when we will get popped, be aware that we told you this day that this is how it's working. Maybe think of using the delegated system, which exists in most of the IDPs, rather than letting people sign in for you, throwing them the laptop and say, hey, sign in for me, do this. So, shared authenticator, very powerful tool. Seems very simple, but if you don't have a query for this, build one.
Thanks, Didi. Yeah, and the last piece about the MFA is bypass. And bypass prevalence, or like bypass usage, bypass code, is a very interesting indicator of company policies and loopholes in company policies. We see a lot of employees trying to make their life easier, and for someone probably like to use a static bypass code, it's easier than fingerprint, but still knowing that how many employees use bypass, why they're using bypass codes, can help you to better understand your overall access policy, user preferences with how they want to work, and maybe you can work that further to see how to make their lives easier with that. A few examples in the accounts lifecycle, from the account lifecycle perspective. One of the interesting things that we see is we hear many customers they're losing control over accounts that were created, deleted on a daily basis. There are so many APIs, so many automation in this place. So like the IT team, they don't actually know what's happening. They know approximately that they have 500 employees in the system, but they don't know to tell, okay, how many people joined this week, or maybe this is the easiest part, maybe. So we hear a lot of questions, okay, show me who joined, like, give me a report. What accounts, and when I say joined, it doesn't mean like a human, right? It might be a machine, it might be a token that was created. Show me those accounts. And so this is easy. And many IDPs provide us information who joined. What many IDPs make harder to find is, is to show, for example, who joined and who was deleted at the same day. Because it's kind of a different type of a report. And suddenly, like when you have this kind of visibility, you can see that you might find a service account that was created for a few hours. It logged in, it did some actions, and was deleted. Maybe it's okay, and maybe this is how this account's supposed to be. But to connect it to the identity graph story, you want to know who created, who on this account, and if you have questions because the account used certain IP or application that you don't like, you can go and ask the person who created it, like, hey, what's the story of it? Is this legitimate? The last piece, sorry, I'll skip you in the sake of time. The last piece that I wanted to show you is license utilization or application utilization. Like once you have a visibility on like it's, let's look at it like not from a user perspective, but from like an application perspective, right? How many people using Salesforce? We see that many of the sensitive apps of the organizations, they have about 30% utilization. And it's first, maybe you can get rid of all the expensive licenses, or Microsoft seats if you have inactive accounts that kind of sit on E5. Or you can also ask yourself, like if I have 60% of my accounts never used Salesforce, maybe they don't need this access. Maybe let's just kill it, and if somebody will need it, he will ask again. Yep. But it's funny. It's like straightforward. But when we show this to organizations, many organizations, they were like, we were joking. They wanted to unsee this because now they need to do something with this, right? Like when you come to an organization, yeah, this is like, you have 40% of your accounts have non-MFA, and they're like, get the hell out of here. We don't want to do business with you because suddenly they need to do something with it. Thank you. I'll pause here. We almost at time. I really appreciate your patience. Thanks for coming to Identiverse. Let's do a commercial for our booth.
Yes.
Cisco.
Ginger, what's our booth number?
Oh, I think it's
1301.
Yeah, it's
1301.
It's a big one. You
Yes.
cannot miss it.
Yes.
It's huge.
I'm on booth duty between 2 and 6 today. Feel free to come in if you have questions and you don't feel comfortable asking in front of everybody. Feel free. I'll answer as much as needed. But I think we do have a couple minutes for questions if anybody has questions. So, anybody? Anything?
I have one.
Yeah. And after that, yes.
You mentioned Elastic for the graph.
Yes.
Never heard of that.
Elasticsearch has a graph API. It's actually really, really nice. I think it's supported from 5.2 and above.
Okay.
And all you need to do is, as long as you create the documents with a linked format, you can create a graph on top of Elastic.
Okay. Oh, thanks.
We use the Amazon version because we're cheap. So we use OpenSearch.
I'm going to ask a general question.
Yes.
Maybe for the entire audience. Will the presentation be available?
That is beyond my skill set to answer. I need somebody from the conference.
We can
Yeah.
we send it to the
I think the conference is going to make it available, but that's a conference question, not an us question. Yes, sir.
Two questions. Did you apply at school?
What?
OORT, did you apply that?
Cisco acquired Ort. I did not acquire. I found it. I found it. Cisco acquired, which makes me very happy.
The next question is that how do we make use of that? Let's say we don't want any of this Cisco, but let's say maybe the identity graph is what we want to use.
Yes.
What would be like,
I think this is a booth question. That's a booth question. Lady with a pink cardigan in the back. You asked me. I think you need to come closer and we'll kill the mic.